our next topic is on application of derivatives. And under that, we have quite a few topics to discuss. And you'll be starting today with rate measure. Okay, right. Uh, like I've been talking about what differentiation is. We've been discussing what differentiation is quite a bit from a long time, right? I've been saying differentiation is nothing but comparing. It's nothing but comparing two quantizable parameters. That's the easiest and the best way to define what differentiation is all about. Now, in this chapter, we're going to see the importance of differentiation and what it can do to us. And it's your job to relate this to everything around you. Now, one such topic is something called as a rate measure. All right. So what you're going to do here is you're going to compare a parameter with respect to another parameter. For example, let's say I compare position with respect to time. If you were to compare a position with respect to time, I think you should already know the answer by now. Position with respect to time should give you velocity. Simple, right? Position should give you comparing position with respect to time will give you velocity. Now, also keep in mind the difference between dy and delta y. Remember, your dy or dx means it's just a very, very small change. A very, very small change. Whereas a delta y on the other side is a larger change. All right, that's the difference between the two parameters. All right, so dy by dt would probably mean velocity if y is position and time and t is time. So the same way, I can also compare area with respect to length. Let's just say I do that. Okay, let's say I compare area with respect to length. If I were to say area with respect to length, dA by dl, then I have my numerator being in meter square and my denominator being in meter. And my unit would be simply nothing but meter itself. Whereas in this case, my position is measured in meters, of course. Time is measured in seconds, therefore meter per second. Quite easy, right? So you don't have to worry, it'll sink in to you much more easily when you start doing numericals. So keep in mind the units. So you will get a few questions, and it's important that you acknowledge the importance of units. I've got a question from the exercise. I've got a random question from the exercise, and we're going to discuss how to solve this question. All right, we're going to see the importance. How do you read this question mentally, and how do you represent this at the same time? All right, so let's go about the question. The question simply says, we have a balloon which remains spherical on inflation is being inflated by pumping 900 cubic centimeters of gas per second. Find the rate at which the radius of the balloon increases when the radius is 15 centimeters. All right, so we pretty much know that we have a sphere with us. Let's represent the sphere with this thing here. All right, so the volume of this cube is changing at a rate of 900 cubic centimeters. So let me go ahead and write the units down. Cubic centimeter per second. So do you need my help for this? Clearly not, right? So centimeter cube per second. What does centimeter cube per second mean? Centimeter cube represents volume and second represents time. So you clearly know somewhere that it is nothing but the change in volume with respect to time. That's what is given to you in the question. So you see how important the units play a role here. Now the question is asking us to find the rate at which the radius of the balloon increases when the radius is 15 centimeters. The rate at which the radius is increasing, the rate at which the radius is changing. So the question is clearly asking you how to find out how is the radius changing. Now, the other quantizable parameters by default itself is time. The clue is given by the word rate mentioned here. So rate is usually with time. So we have a parameter compared with time. Also, since we already have cubic centimeter per second mentioned here, so we already know time is a factor to be compared. That's how I get to know I need to find this. All right, quite easy, right? Next, let's say the volume of the cube This is the cube, right? Volume of a cube is what? 4 by 3 pi r cube. Simple, right? 4 by 3 pi r cube. That's a volume. Now we know this data for sure. Now we need what's also given to us is how this volume is changing. So let's write on the formula 4 by 3 pi r cube, and we're going to differentiate to see how the volume changes with respect to time. Quite simple, isn't it? So let's differentiate dv by dt and see what we get. 4 by 3 into pi is a constant, of course. I'm going to leave it untouched. I'm going to differentiate r cube. Differentiation r cube is 3r square into dr over dt. Remember to apply your chain rule. Do not forget it. The question is also mentioned when the radius is 15 centimeters. What is dr by dt when radius is 15 centimeters? All right, so we pretty much have all the parameters required here. So let's just not jot down what all we have and what we need. Okay, so dv by dt, check, we know it. 4 by 3, 3 and 3 gets cancelled. 4 by 3 into pi into 3 is a constant. The value for r is given to us. Dr by dt is the only unknown in this equation. So wrap it up. So find out what is your dr by dt. That will be your 900 cubic centimeter per second divided by 4 pi into r square. Right? That's it. That's pretty much it. So get it sorted and you are good to go. Dr by dt. Solve this equation to possible you can and match your answers and you're ready to go with it. 15 square is 225, right? Solve it up and you have your answer in meter per second. Remember, observe the units. It's very, very important you have the units with you really well. All right. Now, this is how I will require you to do the remaining questions on the exercise. Also remember that the volume, rate of change of volume with respect to time, 900 centimeter cube per second, is positive. Positive volume means that the volume is increasing with respect to time. All right. It can also happen that the volume could be reduced. It could be minus 900 centimeter cube per second. That means the volume is reducing with time. Now I want you to go ahead and start all the questions in the exercise, and wherever you have a doubt, mark it and leave it. During a live session, we'll go ahead and solve those doubts. All right.